Welcome back to Pleopod, the podcast that demystifies the future of tech. Today, we're venturing into the stratosphere, perhaps even beyond, to talk about AI, data centers, and a potential game changer, orbital computing.
Orbital computing. It sounds like something straight out of science fiction, Armin, but the rumors are that Google is seriously exploring this with SpaceX.
Exactly, Maya. We're talking about Google's internal initiative, reportedly codenamed Project Suncatcher, which aims to deploy AI data centers on satellites. And the word is, they're in discussions with SpaceX for launch services.
That's a massive undertaking. What's driving this? We've got plenty of data centers here on Earth, right?
That's the crux of the problem. The demand for AI compute power is exploding, and it's placing an enormous strain on terrestrial infrastructure. Power grids are struggling to keep up, water resources for cooling are becoming a concern, and you often face long wait times just to get connected to the grid. Vacancy rates for data centers in major U.S. markets have reportedly fallen below 3%.
Wow, that's tight. So the idea is to take the data centers off-world to bypass these ground-based limitations?
Precisely. The vision for these orbital data centers is to use solar-powered satellites. The sun provides a virtually limitless and uninterrupted energy source in space, decoupling AI compute from Earth's power grid and its associated environmental constraints.
Uninterrupted solar power in space sounds fantastic for energy needs. But what about the other side of the coin? What are the biggest hurdles to making this work?
There are quite a few. For starters, there's the sheer cost of launching all this hardware into orbit. Google's internal research suggests that for these orbital data centers to be economically viable compared to terrestrial ones, launch costs need to drop to around $200 per kilogram.
That's a huge reduction from current costs. And beyond the launch, what about operating them up there?
That's where things get really technically challenging. You have to consider cooling. How do you dissipate heat effectively in the near vacuum of space? Then there's the harsh space environment itself. The intense cosmic radiation can wreak havoc on sensitive electronics. Protecting the hardware and ensuring error-free AI inference at scale in those conditions are significant engineering feats.
So it's not just about getting it there, but keeping it running reliably and affordably.
Exactly. SpaceX, as you know, has been a major player in driving down launch costs with reusable rockets, and they've even filed plans with the FCC to launch a massive constellation of satellites intended to function as distributed AI data centers. This aligns with Google's goals, though their own projections for cost parity hinge on those sub-$200 per kilogram launch prices.
When might we actually see this? Is this something for the next decade or further out?
Google is reportedly aiming to launch its first prototype satellites for Project Suncatcher by early 2027. That's actually quite soon, which speaks to the urgency and the potential they see in this approach.
Early 2027. That's ambitious. It feels like we're on the cusp of a new era of computing infrastructure, moving beyond just physical limitations on Earth. It certainly does. If successful, this could fundamentally change how and where we deploy massive AI workloads, opening up possibilities we can only begin to imagine. The intersection of AI, space technology, and renewable energy is truly fascinating.
It really is. We'll definitely be keeping a close eye on Project Suncatcher and Google's progress with SpaceX. Thanks for breaking this down for us, Armin.
My pleasure, Maya, and thank you to our listeners for tuning in to Pleopod. Join us next time as we explore another frontier of technology.